Now we're going to work on combining like terms. In order to add or subtract, you have to have the same variable and exponent. And again, with multiplication, we have ways of showing multiplication without worrying about it being the same variable and exponent. But with addition or subtraction, we'll take a look at number 42 here. You have to have the same variable and exponent. Maybe I'll try zooming in a little. This might be a little bit small for you. So let's see. We have an x to the third here, and we have a negative 1x to the third here. So those are like terms. All right. I have decimal here, so this 1. Remember, where to put? I'm going to write this way up here. Negative x to the third is really negative 1.0 x to the third. It's just this 1.0, we're not usually required to write it. And again, usually it would just be a 1, but since we're working in in decimals, I'm going to want 1.0. All right, so x to the third is just going to come along for the ride. I'm not going to worry about that in my calculation. All right, but I have 3.8. Where to do this? I'll do my calculation over here. We have 3.8, and we're subtracting 1.0 because that's negative. So we're left with a positive 2.8. Okay, so this x to the third is 2.8 x to the third. And let's see our next like terms. This is x to the first power, and over here we have an x to the first power, no other. So that's negative 6.1x and positive 1.1. When I combine them, the negative is larger, so it's going to be a negative. All right. The x is just going to come along for the ride, and all I really have to do with calculation-wise is I have a negative 6.1 and a positive 1.1. So make sure this is still on the paper. I'll do it over here. I have 6.1 and 1.1. This one's negative, so my answer is going to be negative. I'm subtracting because the signs are different. 5.0. Obviously, you could just call this a negative 5, but since we're in decimals, I'll stay in decimals. All right, then the last one to worry about is, oh, by the way, when you combine these two terms, the result of these two is down here, and these are gone. It might help you to cross that stuff out after you've used it, okay? And again here with x to the first power, when I combine them, the result is down here, and these are gone, all right? So that's all gone. This is all gone. So the only thing left standing is this positive 11.8 and negative 8.4. When I combine them, the result will be a positive something, all right? And we'll just do our calculation, let's say right here. 11.8, 8.4. Oops, I didn't need to borrow, did I? Okay, so 8 subtract 4 is 4. Here I do need to borrow, so that's a 0 and that's a 10. And that would give us 2.4. And the positive is larger, so we end up with plus 2.4. Okay, so this would be the answer for number 42. And let me see, number 43 might look quite a bit different, and it's actually the same thing going on with number 44. Write the perimeter of the figure as a polynomial and then simplify, the polynomial. All right, so I'll move this back. If Remember, the perimeter, you simply add up all the sides. So if this side right here is 3x plus 3, that means this side is 3x plus 3 as well. Units, they could have said feet or something, but I'll just put units. And then again, if the bottom is x squared minus x plus 11, the bottom is that, then the top must be the same, x squared minus x plus 11, and I could put parentheses in the word units. So all they really want us to do is add up all four sides. Okay, so I'm going to slide this up a little bit, and I'll just I could string them out, but I think what I'm going to do is just stack up our like terms. Alright, so I have x squared negative x positive 11. So here's, I'm going to zoom out a little bit here just to give us some more room. Alright, so for this one, x squared negative x positive 11, that's taken care of. For this one here, x squared negative x positive 11, that one's taken care of. Let's get these smaller ones. Okay, 3x plus 3, I'm going to stack that. I don't know if this is helping everyone in the world, but maybe I'll get this total and that total and then combine them. Okay, because if I put 3x plus 3 down here, we're going to have some different signs going on, and it might look a little bit confusing. So we've got 3x plus 3, that's that one, and then 3x plus 3, that's that one. Alright, so we've taken care of all four. So this is really 6x plus 6. And over here, we're adding all these. This is 2x squared minus 2x plus 22. There aren't enough 2's in this problem. And now it might be a little bit easier to stack them up here. So this 6x plus 6, I need to combine it with this. So I'll just put 6x plus 6. Alright, so that's that one. And when we combine the whole thing, slide this up even more, we have 2x squared. Okay, negative 2x positive 6x leaves us with a positive 4x. And then 22 and 6, both positive, leaves us with 28. So we represented the perimeter of the polynomial, the perimeter of the figure as a polynomial. So I should maybe put this in parentheses with the word units. Usually it would be feet or meters or something, but they're just saying units. So this is the answer. And again, instead of stacking these up as I did, I could have just strung them out across the page and indicated like terms the same way, but it just seemed a little bit easier to stack them up here. Okay, so let's see, 43. We'll take a look at 46, and I think we can zoom out a tiny bit here. There we go. 46, there's a fair bit going on this one. But again, it's just combining like terms, so as long as you have the same variable and exponent, you simply combine your like terms. Alright, we have x to the fourth here, and looking across you have an x to the fourth here, so that's positive. This one is positive, so when we combine those, we get 18x to the fourth. Okay, and I've used that up, so maybe I'll cross it out. Moving along to the next one. We have x to the third, y to the third, and here you have y to the third, x to the third. The order doesn't matter, so these are like terms. Okay, it's the variable and the exponent is the same. That's what's important. So this is negative x to the third, y to the third, negative 11, x to the third, y to the third, and a positive 6, x to the third, y to the third. So it's going to be negative because this is larger, and you basically just work with the coefficient of the term. So negative 11 and positive 6, that yields negative 5, and x to the third, y to the third just come along for the ride. And I just chose to put x first. Okay, you could have written a y first, it wouldn't matter. So I've used that one up, I've used that one up, and the only thing left to worry about are 2 and 12. When you combine those, you get a positive 14. So we simplified the polynomial. There's nothing else you can do here, by the way. Then we'll take a look at number 47. And in this case, you're starting off with a pair of sets of parentheses. Here, they don't really convey much meaning. There's nothing in front, so you could consider a positive 1 being there. To get rid of the parentheses, I would send in a positive 1 and multiply each term. But I think you can see nothing changes. So basically what we say is just drop the parentheses. So that would be 10y plus 6, or 10y and a positive 6. Here, if you want to think of a 1 as sitting in front of the parentheses, it's fine. But it just seems like maybe a little extra work to think of that. But you're basically going to send in a positive 1 to each term and multiply, and nothing changes. So again, we just drop the parentheses. This is a positive 9y. It was positive, and we multiplied by a positive. So it's still positive 9y, and that's still negative 11. All right. And now we're just going to combine our like terms. You have y to the first power, y to the first power. So when you combine those, you have 19y to the first power. And when you combine your positive 6, negative 11, you get negative 5. All right, so 19y minus 5, that is your answer. You cannot tell me what y is equal to because there's no equal sign anywhere in this problem. Okay, this is all you can do right here. 47, we're also going to take a look at number 50. Okay, 50 is right here. This one's a little bit more involved because we have a negative sign. Let's see, I'll use this one. This negative in front of the parentheses here on number 50 is very important. Maybe I'll try to zoom in a little. I don't know how good this is for y'all. Okay, in front of this set of parentheses, there's nothing, so we went over, you can just drop them. All right, so you're going to have 8x to the 5th plus all of this just sitting here with no parentheses. But for this is the negative of everything in here. Okay, if you want to think of it as a negative 1, that's perfectly fine. Anything next to parentheses means to multiply. So I'm going to multiply negative 1 times each of these terms. If there were more terms, I would just keep sending the negative 1 to each term inside the parentheses. Okay, whatever's in parentheses has to get hit. So negative 1 times a positive 2 is negative 2. Negative 1 times negative 3x to the 6, positive 3x to the 6. Negative times positive is negative 8x to the 7th. And then finally, negative times negative is positive 3x to the 5th. Okay, so basically the shortcut, when this negative's in front, all the signs change inside. Well, it wouldn't affect exponents, you notice. They didn't become negative. That's a whole different arena. All right, so for our first set, I could just write the like terms underneath here. And in fact, once you start having this many terms, I think it's easier to do that. If I write 8x to the 5th, 6x to the 7th, plus 7, 5x, if I write all that over here, I'm going to have to look back and forth to combine like terms, whereas this 8x to the 5th is going to combine with this right here. Okay, so I'm going to put plus 8x to the 5th. All right, I've taken care of that one. 6x to the 7th is going to sit right under this x to the 7th. So that's plus 6x to the 7th. I've taken care of that one. This positive 7 is going to sit right underneath this negative 2. So I'll put my positive 7 right there. Taken care of that. And the last thing I have is a positive 5x to the 6th. It'll sit underneath this x to the 6th. So plus 5x to the 6th, and that's taken care of. Okay, and now everything is stacked up. I think it's a little bit easier to keep track of everything. So 8 and 3, that would be positive 11x to the 5th. Negative 8, positive 6, that's going to be negative 2x to the 7th. These are both positive, so we'll add and we'll get positive 8x to the 6th. And then finally, negative 2, positive 7 gives us a positive 5. At this point, you don't really need that. But standard form in mathematics is to write the expression with descending powers of exponents. This has the same meaning as what I'm about to write, but standard form, it's preferred to have your largest power first. Okay, so this will be negative 2x to the 7th plus 8x to the 6th plus 11x to the 5th, and finally our plus 5. Okay, so this is the preferred way to write the answer. And it has to do with, in mathematics, we're most concerned with these exponents because they're so powerful, and that says a lot about what's going on in this polynomial. And let's see, we're going to get a couple more here. Oh wait, number 50? Yeah, that takes care of it for this one.